Good morning all. Now I am going to explain about EMF equation of a transformer. Okay, already we know that when AC voltage is given to the primary winding, see here, when AC voltage is given to the primary winding of a transformer, it will produce a alternating flux, right? This flux which links with the primary winding, it will, okay, whenever current in coil changes, flux linkage in the coil also changes, hence EMF is induced, right? Okay, we need to calculate that induced EMF. Okay, first of all, in this EMF equation, it will produce a flux in a transformer core, right? That flux phi is equals to phi m sin omega t, right? Already we know that according to Faraday's law, the self-induced EMF is given by E1 is equals to minus N1 into d phi by dt, right? Already we know that phi is equals to phi m sin omega t. Substitute that value here, you will get E1 is equals to minus N1 into d by dt of phi m sin omega t. You will get E1 is equals to minus N1 into phi m as constant. D by dt of sin omega t value will be cos omega t into omega, right? That value E1 is equals to minus N1 omega into phi m into cos omega t, right? That means that is equals to E1 is equals to minus N1 into omega into phi m into cos omega t can be written as sin of 90 minus theta, right? This sin of 90 minus theta can be written as sin of omega t minus 90. If I take minus as common, right, then minus of minus I will get plus here. That is E1 is equals to N1 into omega is equals to 2 pi f into pi m sin omega t minus 90. Okay, after that the induced EMF is E1 is equals to 2 pi f omega will 2 pi f into N1 into phi m into sin omega t minus 90, right? Now see here, from this equation, if I substitute omega t equals to 0, sin of minus 90, that is minimum value. Omega t equals to 90, sin 0, 0. If I substitute omega t is equals to 180, I will get sin 90 value is 1, right? That means if I substitute at omega t is equals to 180 degrees, then only I will get induced EMF as maximum. Okay, that is E1 maximum is equals to, right, E1 from this equation, E1 maximum is equals to, when I substitute omega t equals to maximum, right, this value will be 1, then you will get 2 pi f into N1 into phi m, right? Okay, this is the E1 maximum. In case of sinusoidal voltage, RMS value is equals to Vm by root 2, right? Maximum value divided by root 2, that is E1 RMS is equals to 2 pi f into N1 into phi m by root 2, that is equals to root 2 into pi into f into N1 into phi m. Then E1 RMS is equals to 4.44 f into N1 into phi m. Okay, this is the EMF equation of a transformer. E1 is equals to 4.44 f into N1 into phi m. Again, flux phi m is equals to Bm into An, where Bm is maximum flux density, An is net cross sectional area. Okay, similarly if I solve induced EMF on secondary side, that is also I will get E2 is equals to 4.44 f into N2 into phi m. This is equation 2. Okay, now coming to the observations from this EMF equation. Okay, if I write E1 by E2, equation 1 divided by equation 2, that is E1 by E2 is equals to, right, E1 by E2 is equals to 4.44 f into N1 into phi m by 4.44 f into N2 into phi m, right? 4.44 f phi m will be cancelled, right? That is E1 by E2 is equals to N1 by N2. Okay, next, again from this EMF equations, from equation 1, E1 by N1 can be written as 4.44 f into phi m. Similarly, from equation 2, E2 by N2 is equals to 4.44 f into phi m, right? These two values will be equal. Okay, from these two results, the conclusion will be EMF per turn on the primary side is equals to EMF per turn on the secondary side. From this equation also, again you will get E2 by E1 is equals to N2 by N1. Okay, already these points will be discussed, right? If I substitute phi m is equals to Bm into An, E1 is equals to 4.44 f into N1 into Bm into An. Similarly, E2 is equals to 4.44 f into N2 into Bm into An. Okay, in this way we can derive the EMF equation of a transformer. Okay, now we will solve one problem on EMF equation of a transformer. Okay, see here, a single phase 2200 by 250 volts, 50 Hz transformer has a net cross sectional area of 36 centimeter square and a maximum flux density of 600 Weber per meter square. Calculate the number of turns on primary and secondary of a transformer. Okay, first we need to write the given data. What is given? 2200 by 250 volts. That is nothing but nameplate details of a transformer. That is E1 by E2. Okay, indirectly is given E1 by E2 value as 2200 by 250 volts. That means E1 value is 2200, E2 value is 250 volts. Next, supply frequency is given, F is equals to 50 Hz. Next, net cross sectional area, AN value is given, right, 36 into centimeter square. See here maximum flux density in Weber per meter square. Then convert this given area into meter square. 1 centimeter is equals to 10 to the power minus 2 meters, right? That is 36 into 10 to the power minus 2 whole square. You will get 36 into 10 to the power minus 4 meter square. Bm value is 600 Weber per meter square. Okay, already we know that E1 is equals to 4.44 F into N1 into Bm into An. Bm value is known, An value is known, F value is known, E1 value is known. Then N1 is equals to E1 by 4.44 F into Bm into An. That is equals to 2200 divided by 4.44 into 50 into 600 into 36 into 10 to the power minus 4. That is N1 is equals to approximately here 4.58. Okay, tons always represent a fixed value. That means either 4 or 5, right? 4.58 near to 5, right? That means number of tons will be 5 tons. If the value is less than 4.5, then you can indicate 4 only. Similarly, N2, E2 is equals to 4.44 F into N2 into Bm into An. Then N2 is equals to E2 by 4.44 F into Bm into An, right? If I substitute all those values, you will get N2 value. Okay, in this way we can solve problems on EMF equation. Okay, thank you all.